Good morning, students. As in the previous video, we had discussed about the indirect methods for measuring large distances, such as triangulation method, laser method, radar method, sonar method, etc. These methods we had discussed. These are the indirect methods which we had discussed to measure the large distances. We had also seen how the a small length can be measured by the help of direct methods, that is by the help of microscope, electron microscope and tunneling microscope. Now today we will discuss one of the indirect method, most popular method, one of the most popular indirect method for measuring the small distances, that is oleic acid method. So note it down. Indirect method, indirect method for estimating a small distances. A small distances. Indirect method for estimating a small distances. And in this estimation, we will do estimation of size of an oleic acid molecule. We will estimate the size of an oleic acid molecule, and what process we adopt for this. We will study the process which we adopt for the estimation of size of an oleic acid molecule. We understand the steps one by one, and we be very much careful and imaginative regarding to understand this concept for indirect method of estimating a small distances. So with very much concentration, try to understand this method. I want to make you clear that oleic acid is a soapy molecule. Soapy liquid. It is a soapy liquid having the molecular size of the order 10 to the power minus 9 meter. Soapy liquid having molecular size of 10 to the power minus 9 meter, and we have to estimate this much size by indirect method of measurement. So first of all, what we will do, we will dissolve 1 centimeter cube in volume 1 centimeter cube of oleic acid in 20 centimeter cube of alcohol. Dissolve 1 centimeter cube of oleic acid in 20 centimeter cube of alcohol. Our first step is, whatever the oleic acid we had caught or we have for the estimation purpose of its molecular size, we will take 1 centimeter cube by volume of that oleic acid and dissolve that 1 centimeter cube of by volume in 20 centimeter cube of alcohol, and we will get a solution. oleic acid alcohol solution we will get. And again then what we will do in second step, redissolve redissolve 1 centimeter cube of this solution in 20 centimeter cube of alcohol. Clear? These are our first two steps. First, what we had done, first we had dissolved 1 centimeter cube of oleic acid in 20 centimeter cube of alcohol. After that, whatever the solution we had got, we had redissolved that solution in, we had taken 1 centimeter cube of that solution which we had obtained in the first stage. That solution will be redissolved in 20 centimeter cube of alcohol. Now tell me, what will be the concentration of oleic acid in 1 centimeter cube of alcohol? Concentration of oleic acid, concentration of oleic acid in 1 centimeter cube of alcohol, that is equal to, look at here. Here the concentration is 1 upon 20, 1 upon 20. So 1 upon 20 into 1 upon 20, that is equal to 1 upon 400 centimeter cube. 1 upon 400 centimeter cube is the concentration of oleic acid in 1 centimeter cube of alcohol. Means whatever the solution we had got here, I had taken 1 centimeter cube of alcohol. What is the concentration of 1 centimeter cube? If we take 1 centimeter cube of this solution, then what is the concentration of oleic acid? That concentration is 1 upon 400 centimeter cube. Now we can determine the approx volume of each drop V centimeter cube. Clear? This is the concentration of oleic acid in this solution. This is the concentration of oleic acid, and each and every drop of this solution, we approximate volume of each and every drop of this solution, we had assumed that volume is V centimeter cube. If we are dropping n number of such drops in a water, taking in a broad vessel. Suppose there is a broad vessel, and from this solution we have dropped n drops over the water in that broad vessel. So then what will happen? If we drop n drop, then what is the solution? What is the concentration there? For n drops of solution on the surface of water taken in a broad vessel. N drops of solution on the surface of water taken in a broad vessel. So what will happen if we drop n drops of solution on the surface of water taken in the broad vessel? Then after some time, it will happen that alcohol evaporates and thin film of oleic acid left over the water surface. So what will happen? Alcohol evaporates and thin film of oleic acid left over the water surface. Thin film of oleic acid left over water surface. Now I am briefing what steps we had followed till now. First of all, we have to find out the concentration. We have to find out, so we have taken some oleic acid, and from that oleic acid we had just dissolved 1 centimeter cube of oleic acid in 20 centimeter cube of alcohol. After that, we had made a solution of oleic acid and alcohol. From that solution we had taken 1 centimeter cube of solution, and again we had dissolved that 1 centimeter cube of solution in 20 centimeter of cube of alcohol. Now we had got the concentration of oleic acid in 1 centimeter cube of alcohol as 1 upon 20 into 20 centimeter cube, that is 1 upon 400 centimeter cube. Okay. Now we had approximated or determined the volume of each drop of the oleic acid V centimeter cube. Then n number of such volumes is n into V centimeter per cube. Now we had dropped n number of drops on the water surface in a broad vessel, and in that case water, after some time, alcohol evaporates and a thin layer of oleic acid remains on the water surface. Now volume of n drops of that solution. Volume of n drops of that solution, that is nV centimeter cube. nV centimeter cube. Amount of oleic acid in that solution equal to nV upon 400 centimeter cube. nV upon 400 centimeter cube. Now thickness of film. Thickness of film. Oleic acid film, after evaporation of alcohol, whatever the oleic acid film we are going to obtain, that thickness T, and this thickness can be given by volume of the film upon area of the film. Area of the film. Suppose area is A and volume, we had calculated volume, that is equal to NV upon 400 centimeter cube. So it will be NV upon 400 into A centimeter. Now, if the volume, if we are considering film is monomolecular, whatever the film we had obtained over the water surface, that film has single molecules of folic acid, so it is monomolecular. Then the volume is equal to area into thickness. Thickness area means volume is equal to area length into breadth into height. So length into breadth becomes area. So area into height. And if it is monomolecular, supposing 1 centimeter, then area and area cancel out, and the thickness will be n upon 400. And this value we approximately get 10 to the power minus 9 meter. This is the way, this is the technique to find the approximate order of thickness of oleic acid molecule. So this is the technique, this is the order of thickness. Order of thickness. This is the order of thickness of oleic acid molecule, and it is approximately equal to 10 to the power minus 9 meter. In this way, we can, this is the indirect method to find out the small sizes, and one of the method which is adopted to find the molecular size, which is of the order 10 to the power minus 9 meter, is the oleic acid method. Now we will discuss, we had already discussed the direct methods for measuring the small distances. Now some practical units of length. 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 The first is astronomical unit. First one is astronomical. Astronomical unit. And this is the astronomical unit is what? Astronomical unit. Astronomical unit, it is called as AU. Astronomical unit, it is called as AU. And this astronomical unit is nothing. It is the mean distance between Sun and Earth. Mean distance between Earth from the Sun. Mean distance of Earth from Sun. Mean distance of Earth from Sun. And 1.496 into 10 to the power 11 meter. 1.496 into 10 to the power 11 meter. Or you can say that 1 upon 5 into 10 to the power 11. As we had discussed astronomical unit in Copernicus method to find the distance of superior planets, inferior planets from the surface of the earth. We had discussed the astronomical unit. So astronomical unit is the mean distance, average distance of earth from the sun, and it is considered as 1.49 into 10 to the power. It is a larger distance. Next is light year. Second one is light year. Second one is light year. Light year. What is one light year? As clear from the name, light year, it is the distance traveled by the light in vacuum with the 3 into 10 to the power 8 meter per second in 1 year. Distance traveled by light in vacuum with what speed? 3 into 10 to the power 8 meter per second in 1 year. Then what is the value of distance? 1 year means 365 days into 24 into 60. 1 day 24 hours, 24 hours into 60 into 60 seconds. Meter, this is the distance. So 365 days, 1 year is that much of time, and if we are going to multiply this speed with this time, then we will get the distance. Then we are going to get the distance. So for getting distance, what is 1 light year? 1 light year is equal to 3 into 10 to the power 8 meter per second into 365 into 24 into 60 into 60 seconds. Cancel it out and calculate the value. You will calculate it. Now, next practical unit is parsec. Parsec. Third one is parsec. Parsec. It is distance at which an arc of 1 astronomical units subtends an angle of 1 second. Subtends an angle of 1 second. Means distance at which an arc of 1 astronomical unit. This is the arc of 1 astronomical unit. Means arc of 1 astronomical. Earth is revolving around a sun, and it is subtending an arc of what is the mean distance? What is the mean distance of the Earth from the sun? That much amount of distance it covers on its arc. Means if sun is here, Earth is revolving, the mean distance is 1 astronomical unit, and if that much distance is subtended by the Earth such that the angle after subtending 1 astronomical unit, the angle becomes 1 second. The angle that Earth subtends the angle at the center of at the sun or at the center of this orbit is 1 second. That is called as parsec. 1 astronomical unit, and it is subtending theta is equal to 1 second. Then this distance r is equal to 1 parsec. R is equal to 1 parsec. This is called 1 parsec. It is abbreviation. 1 parsec is equal to 1 parallatic second. This is called as 1 parsec is equal to 1 parallatic second. R is equal to, जैसे as you know that theta is equal to L upon R, so it implies that R is equal to L upon theta. R is equal to L upon theta. R is equal to 1 parsec. Length of the arc is 1 astronomical unit and theta is equal to 1 second. Theta is equal to 1 second. So now we are going to find out this value. What will be this value? So 1 parsec is equal to 1 astronomical unit, that is equal to 1.496 into 10 to the power 11 meter upon 3600 into pi upon 180 radian. Pi, this is the distance, and 1 second, 1 degree has 60 minutes and 1 minute is equal to 60 seconds. So this value in degrees, to convert 1 second into degree, 1 upon 3600, and then by that we have converted into radian. So it will give the value 3.084 into 10 to the power 6 meter, approximately equal to 3.1 into 10 to the power 16 meter. This is the value of 1 parsec, 1 parallatic second. 3.1 into 10 to the power. Now there is a relationship between light year, parsec and astronomical unit. Relation between light year, parsec, so 1 light year is equal to 9.5 into 10 to the power 15 upon 1.5 into 10 to the power 11, that is equal to 6.3 into 10 to the power 4 astronomical unit. 1 parsec it is equal to 3.1 into 10 to the power 16 upon 9.5 into 10 to the power 15, and it is equal to 3.26 light year. So 1 parsec is greater than 1 light year is greater than 1 astronomical unit. 1 parsec, this is the relation between parsec, light year and astronomical unit. Now this is the practical units. These are the general practical units which are used for the measurement of large distances. Now to measure the small distances, some practical units for measurement of small distances. To measure a small distances, we have to measure small distances. First one is 1 micron or 1 micrometer. It is equal to 10 to the power minus 6 meter. Second, 1 angstrom. 1 angstrom, it is equal to 10 to the power minus 10 meter. Third, 1 X-ray unit. 1 XU, it is equal to 10 to the power minus 13 meter. And 1 Fermi. 1 Fermi, it is also called as femtometer, 1 FM is equal to 10 to the power minus 15 meter. These are the practical units for measure small distances. Now, a brief view on the ranges which we measure in length means, while discussing the range, we want to say that or want to visualize you that up to how much small distance to how much big length we are used to measure in physics. So range of length in meter. Range of lengths in meter. Radius of visible universe. That is radius of visible universe, that is equal to approximately 10 to the power 26 meter. Radius of Milky Way. 10 to the power 21. Distance of nearest star, it is equal to 10 to the power 6, 10 to the power 16 meter. 10 to the power 16 meter. Height of human being, various things are in between this. Height of human being, that is equal to 10 to the power 0. Radius of virus, 10 to the power minus 7. This is all, these are order of size. Radius of atom, radius of atom 10 to the power minus 7 meter. 10 to the power minus 7 minus 10 meter radius of atom. Radius of nucleus, nucleus 10 to the power minus 14. Radius of proton, ten to the power minus 15, and etc. All various things are there, but we had discussed from very large values, that is 10 to the power 26 meter to 10 to the power minus 50. So if we are taking the ratio, that is longest distance upon the smallest length, then we get 10 to the power 26 to 10 to the power minus 50, and it is equal to 10 to the power 41. So 10 to the power 41 is the ratio of longest distance to the smallest distance, and you will have to know that you are seeing that whatever the ranges we have discussed, the human height is in middle of these ranges. So today this is all about the length of measuring length, larger length, smaller length, direct methods and indirect methods, all things we had discussed today. Now, in the next video, we will discuss about measurement of time. So, that's all for today, students. Thank you. Have a nice day.